Hello and welcome to my workshop. So today we're going to make the first part for Katie, and that is going to be the main structure block of aluminium off this carriage to link up with this ball screw. And I've coincidental, I've put this ball screw in here and it is exactly the right size for that bearing block. Of course, it's the wrong type of bearing. I need to put ball bearings in, and also thrust washers to stop any backlash. But it's there really, and it's holding this in the perfect position for what we want to do. So what I've decided to do is get some of this. So that's 1 inch by 2 inch or 50 millimeters by 25 millimeters solid aluminium, high grade aluminium. And I am going to cut a piece that is going to fit underneath here down. And that is going to be the main foundation then to hold another bracket coming off to attach to this ball screw here, and the nut rather, and then I'm going to build up here out of aluminium plate to house the motor, and I am going to be able to get this in there. I do notice in the comments a lot of you are saying, oh, order a smaller one. Well, yes, I could do that, but I've got this one now, and I know I can make it fit in there. So that's what we're going to do. I'll give you a little bit of a closer look. And one of the reasons I want to bring you in for a closer look is, and I couldn't believe this when I did it, and that is how well these Sieg lathes are made. These things are, all these parts are ground to very, very high tolerances. And you put see if I can get that on there squarely. If I can get it round so you can see it, maybe. Is exactly 100 millimeters, which is exactly 4 inches. Unbelievable. But the tolerances that these little lathes are actually machined to is phenomenal. So that gives me a little problem, and I'll show you what that problem is when we get over to the mini mill. And of course that problem is, and this is also made by Sieg, and the problem is, you know, this is pretty close to 4 inches, or pretty close to 100 millimeters. So I cannot machine this cleanly. So I'm going to have to do it in two halves. I'm going to have to face this side off first, turn the block over, or I can run this X over 100 millimeters, and in actual fact it's going to be 108 millimeters. And slide this block over a little bit more. So I don't know really how I'm going to manage that yet, but or I might even just take it out, turn it over. I could do that as well, but then I'd have to obviously sort of mic this up to get it exactly the right size, because the jaws of my machine vise, all my machine vices are 4 inches or 100 mils. So, you know, I don't want to go taking anything out of my jaws. So I've written a very small program in ArtCAM Smith, the old program, and I've just actually made a pocket. I've asked it to machine off, and I can sort of edge it in to get the right amount off. And I'll show you how we do that. I've wrote a program in ArtCAM. I've asked it to cut a slot 26 millimeters deep and 8 millimeters wide. I've got an 8 millimeter tool in here, and I know I've got to take about 2 millimeter off this end and 2 millimeter off that end, roughly. So for this first cut, I'm just going to bring it down so it's just touching the top of the material. Okay, so now we'll go to the pendant, which is much more okay. So that's just scratched the top, so I know that is on the top of the material now. It's in about the middle of the material. Actually, I'll take it back a little. That'll do. So now I can zero the X, Y, and Z. Raise the tool up now, off the material. And now we can begin the cut. Exactly 100 millimeters. Now that is the type of accuracy that you can get with these small CNC conversions, but it is necessary to start off with the right machine. Sieg is built to very high quality. So if you want an accurate CNC machine, start off with the right machine. So what I'm saying is, if you're thinking of making a CNC conversion, whether it be a lathe or a milling machine, if you can possibly, go for Sieg. You won't be sorry. I just made this lovely little part, and it is perfect. Earlier I just mic'd it up and showed you that it is perfectly 100 millimeters long, and I've drilled it. Halfway through making this part, I thought, oh, I'll offer it up and, you know, see how things are going, because I don't like to get too far into a part and find, oh bugger, I've stuffed up here. Well, I've sort of had a, not stuffed up, I've sort of had a change of mind midway through making this part. although it would work, it would just mean me layering up 2 pieces of 12mm plate come up here. And to stand out, I'll fetch you in and show you what I'm trying to tell you. Okay, so my original thought was to have this mounted up underneath here, solidly mounted on there, and then 2 pieces of 12mm, and the second piece extended up here to hold the standoff for the stepper motor. And I'm looking at it and I'm thinking, oh yeah, this is going to work, because I'm going to have a 12mm or 10, maybe 12, maybe 10mm bracket coming off the end of here and going over this to screw into here, and that would work. I might have to take a little nick out of this corner here to give it a little tiny bit of clearance, because that is actually, well, it's perfectly up against it. It might be okay. I'm thinking, okay, that'll work. And when suddenly looming in front of me is a 2-inch square block of aluminium, and I could have just gone on there like that, and there's my standout, and have one 12mm plate up here. So that's exactly what I'm going to do. I'm going to remake this in 2-inch or 50mm square. So that's what I'm going to do now. Okay, the next operation is to drill the 2 holes in the top here. Now, of course, on the last piece, it was set up for a 25mm thick piece. So I'm going to set the 0, 0 on this back corner here. And also, I want to give myself just a little bit more clearance off the ball screw. So I'm going to actually trick the machine then. I'm going to take it over that way another millimeter. So let me just have a look through the side door. A little shade more, which will give me that you know, sort of millimeter clearance off the nut. That'll do me. I'm just going to bring it down. This is just a spot drilling, so it's not crucial with the Z, but I will take it down a little touch more. Okay, we're going to call that good there. So I'm going to set Mark 3 now, raise the tool up and set it going. I won't need coolant for this. Okay, this one could get a little messy, so I brought the camera up the far end and opened the side door so you can see in. So I'll just start it going. This is what's commonly known as a peck drilling operation. You notice the drill will peck like a bird and clear the swarf out. I have the peck depth at 1 millimeter, so it will drill 1 millimeter and then fully retract out. Okay, so that's the first part completed. Well, it's a spacer block and it's a main sort of anchoring block for the rest of the axes, and you'll notice it's got a textured finish. It's very smooth, but it still looks textured. This is because I used such a long end mill. It was a 12 millimeter, but it was 60 millimeters long, and you know, doing a side cut, it does tend to, you know, leave a bit of a textured finish like that. I had no other way of doing it. I couldn't stand this up on end and machine it that way because I wasn't sure whether it was square the other end. So to make sure it was square, and in actual fact this does two things for me. It is nice and square now, but I am going to actually clamp or bolt another piece to this to go to the end of the ball nut. So then this makes sure it doesn't slip, it won't move. Aha! Don't know whether you can pick that out. I've got that millimeter gap now, and it's perfect. So now what I've got to do is make a plate to go onto here and over to here to attach the end of this nut to this piece of metal. So that's the next job.